Hello everyone, welcome back. My name is Mr. Kovalt, and in this video I'm going to go over how to solve this problem using conversion factors using the information that they've given us in the problem. Okay, so in this problem they want us to find uh, the amount of volume in liters of a given amount. Now, so again, whenever you're attacking a word problem like this, the first thing you want to do is just pull out the information, pull out the relationships, because those are going to be your conversion factors. Anything that's like a density or a percentage or something that has two units that are 1 unit per some other unit, that's going to be used as a conversion factor. So pull those out first. So in this problem, we have a solution containing a 12.0% sodium hydroxide by mass. So that's going to be a conversion factor. So again, with the percentages, the way you want to understand a percentage is that it is out of 100. Percent means per 100%. So if you remember that a percentage is out of 100, you can then write the equality using that percentage. So here they give us 12.0% by mass. So we can use a mass unit. It doesn't matter what mass unit you use, but you could use a convenient one since they have grams here and here. Why not just use grams? So that way we could use these numbers later. So how do you do this in a conversion factor? How do you use your percentage as a conversion factor? Um, you take 12%, and again, out of 100. So that means that if I have 100 grams of the sodium hydroxide solution, so I'm going to have NaOH, grams, 100 grams of my NaOH solution. That means that out of this 100 grams, 12% of that is the NaOH, grams of NaOH. So that is going to be equal to 12 grams. So 100 grams of solution is going to give me 12 grams, 12.0 grams of the actual substance, in this case, NaOH. So that's how you set up the conversion factor from your percentage. Okay, so what else do they give us? They give us the density. So they give us the density of the solution. And so we could write that. And so this is grams per milliliter. So we could write that as an equality. What that's saying is for every 1.131 grams of our solution, that's going to be equal to 1 milliliter of that same solution. So that if we write that out, it's going to be 1.131 grams of NaOH solution, and that's going to be equal to 1 milliliter of that solution. 1 milliliter of the NaOH solution. And you'll notice that whenever I'm writing this out, I always have three things that I'm writing out: the number, the unit, and the substance I'm talking about. So 1.131 grams of sodium hydroxide solution. So that way, when I'm writing out my conversion factors, I'm not going to make a mistake or get confused about what I'm converting from and to. All right, so now we have this density. They're saying that pure NaOH has a density of 2.130 milliliters. Okay, so we're going to do the exact same thing. So that's saying 2.130 grams of NaOH, not NaOH solution, the actual NaOH is going to be equal to 1 milliliter of NaOH. NaOH. Excellent. Okay, so is there anything else? There's no other information they're giving us as far as conversion factors go. No other relationships. So the next thing we need to do is figure out where we're going to begin and where we're going to end. And that is where you go to the question for. 99% of the time, you're going to find the ending and the beginning of your problem in the question. So I'm going to put an arrow here. Where do I want to go? The goal or purpose or end of your problem is the beginning of the question. Where's the beginning of the question? What volume of the solution in liters? So that's where they want. That's where we're going to end. So we need to know liters. We need to find liters of solution. So what liters of solution must you use in an application that is requiring 1.00 kilograms of NaOH? So this is our ending. Where's the beginning? The beginning is in the question as well. So if you keep reading the question, it's requiring 1.00 kilograms of the NaOH. So that's where we're going to begin. So we're going to start with 1.00 kilograms of NaOH. And we're going to go and we're going to use conversion factors until we get to liters of solution. So in the middle here, we're multiplying by conversion factors. All right, so we have everything we need. Now all we need to do is just set up the problem. So we set up by starting with the beginning. Make sense? So we're going to start with, I'm going to give myself some room over here. So we have 1.00 kilograms of what? NaOH. NaOH. And I'm going to put that over 1 because I want to be multiplying by my conversion factors, and my conversion factors are fractions. They're ratios, one thing over another. So I'm putting this over 1 to create the same thing. Now, the next thing I'm going to do is start multiplying by conversion factors. So I have kilograms, but notice that everything is in grams. So I need to convert to grams. If I'm going to use these, I need to convert to grams. So I need to convert kilograms to grams. So I need another conversion factor. I need an equality. So the way I set this up, how do I figure out what is what? Because this is a metric unit, these are metric units. I need to know the metric unit multipliers. So if you don't know the metric unit multipliers, you got to memorize them. See my video on metric unit multipliers. So I set up the units. So on one side, I put kilograms. So I'll put kilograms over here. On the other side, I put grams. And then I figure out, okay, so which side gets the 1? I always put the 1 with the prefix. So I'm going to put the 1 here at kilograms because kilo is the prefix. And then on the other side, I put the prefix multiplier. So I need to know what kilo stands for. And in this case, kilo is 1,000. So 1,000 of that particular base unit. So kilograms is 1,000 equal to 1,000 grams. So I'm going to put 10 to the third here. So 10 to the third is the same as 1,000. So 1 kilogram is equal to 10 to the third grams. So now I can use this as a conversion factor. So let's get this going. So I have 1 kilogram here. I have kilograms of NaOH on the top. I want to put it on the bottom to cancel out. I need to cancel out my units. So 1 kilogram. So I'm going to put 1 kilogram of NaOH. Remember, I'm always putting number, unit, substance. And then on the top, I put grams, 10 to the third grams. So 10 to the third grams of NaOH. So kilograms of NaOH cancel out. Now I've got grams. Now I can start using these. So where do we want to go? We want liters of solution, the NaOH solution. but we got grams of NaOH. So we need to go further. So we need liters. We need to get from grams to volume. So here we have grams of NaOH, and that's related to milliliters of NaOH. Here we have grams of NaOH related to grams of solution. So that way we're going from grams to grams. So why don't we do that? So we're going to use this. So I'm going to put 12 grams of NaOH on the bottom because I have 10 grams of NaOH on the top, or I have 10 to the third grams on top. So grams on top of NaOH. I need grams of NaOH on the bottom. So I'm going to put 12.0 grams of NaOH on the bottom. So 12.0 grams of NaOH on the bottom, and the other side goes on top. So I'm going to put 100 grams of NaOH solution on the top. So 100 grams of NaOH solution on top. I need to write solution because the solution is different from the NaOH. So now grams of NaOH cancel out. Now I have grams of NaOH solution. So now what's next? I need to get to liters of solution. Okay, so now I have grams of NaOH solution. So if I have a relationship between grams and volume of the solution, I could use that. And here I have grams of NaOH solution and volume of NaOH solution. So I can use that. So let's go ahead and do that. And so I have grams of NaOH solution here on top. So I need to put grams of NaOH solution on the bottom. So here is my grams of NaOH solution. So I'm using the density now as a conversion factor. So 1.131 grams of NaOH solution is on the bottom. And now I can put 1 milliliter of NaOH solution on top. So the 1 milliliter of NaOH solution goes on top. Now grams of NaOH solution cancel out. Now I have milliliters of NaOH solution. But I don't want milliliters. I want liters. So I have to have another conversion factor between liters and milliliters. And so I do the same thing as I did before. Because these are metric units, I can set up my equality. I have to know the prefixes. So I'm going to have milliliter. I'll put milliliter on that side, and I'll put liter on this side. I put a 1 with the prefix. So this is going to be 1 milliliter. And then the prefix multiplier goes with the base unit. So milli, I need to know what milli is. Milli is 1/1000th or 10 to the negative 3. So I'm going to put 10 to the negative 3 there. So now I can use this as a conversion factor to convert from milliliters to liters. So now my next step, I have milliliters of NaOH solution on the top, so I need to put milliliters of NaOH solution on the bottom. So 1 milliliter of NaOH solution is on the bottom, and 10 to the negative 3 liters on the top. 10 to the negative 3 liters of NaOH solution. So my milliliters of NaOH solution cancels out. Now I have liters of NaOH solution. They want liters of NaOH solution. So I'm done. So once you have the unit and the substance that you want on top, you're done with the problem. So now at this point, all you're doing is you're multiplying and dividing to get your answer. So let's go ahead and do that. Okay, so I'm going to use my calculator. So I'm going to start with the top. If it's a 1, I'm going to ignore it. So 1, so 10 to the 3, that's 1,000. So 1,000 times 100, and then times 1, skip that, and then times 10 to the negative 3, so times equals, okay. So now I've got the top done. Now I'm going to divide by everything on the bottom. So I'm going to divide by 12. So divide by 12. And then I'm going to divide by 1.13, 1.131. And then that's it. I'm not going to divide by that. So it equals. And so my answer is 7.368, 7.36811 dot dot dot. I think that's right. So it keeps going. And oh, by the way, this has to be liters. So liters of NaOH solution. Okay, great. We got our answer. So now the last thing we need to do is always figure out if we've got the right number of significant figures. We need to figure out what the right number of sig figs for this answer is. So we go back to our multiplication and division. And remember, the rule for multiplication and division is that your answer should be in the least number of sig figs should have the same number of sig figs as the least number of sig figs you multiply and divide. So we need to go back to the problem here. So here, I'll use a different color. So here we have 3 sig figs. The zeros at the end of your number are significant if there is a decimal point. We do, in fact, have a decimal point. So this is 3 sig figs. This is an exact relationship. 1 kilogram is equal to 1,000 grams by definition. So we can ignore that. Here we have a relationship. So the 12.0 is the percentage we were given a moment ago. So they gave us the percentage. That is a measure. So we do have to keep our eye on the sig figs here. And so that is 12.0. So this 0 again is significant because with the decimal point. So this is going to have 3 sig figs. The 100 there is just by definition, right? So when this, by definition, 12% is 12.0 out of 100, so we can ignore the 100. Here we have a measure as well. So we have 1.131. So this number has 4 sig figs. And again, this is true by definition, so that's exact. So here we have 3 sig figs, 3 sig figs, 4. So the least number of sig figs is 3. So that means your answer can only have 3 sig figs. So we can keep the 7, the 3, and we got to stop at the 6. So everything else gets dropped. Notice that this is an 8. So that means we round this 6 to a 7. So that means our final answer is 7.37 liters of NaOH solution. And that's the answer. So I hope this was helpful. If you like this video, please hit the like button. Make sure you share with your friends, subscribe to the channel, and put a comment in the comment section. Let me know what you think, and if you have any other questions. Thanks for joining me, and have a great day.